Here we are at the last video of this three-part series on dealing with numbers in physics. And in this video, we're going to talk about dimensional analysis. Basically, a fancy way of saying paying attention to your units when you go through and do physics calculations. So dimensional analysis allows you to check if your answer is wrong. So it'll definitely tell you that, and it also tell you if you are on the right track to solving the problem. Are your units at least what they should be? Doesn't mean you necessarily have the correct answer, but it means you're on the right track. So this again is probably best demonstrated by just doing some practice problems, kind of showing you. So let's go back to the note sheet.
Dimensional analysis just is a fancy way of saying track your units. And when you finish a problem or you solve an equation, the units of the value that you the units of the value that you're looking for are going to be equal to the units that you just solved. They have to be, or else you've done something wrong. Okay, so for example, let's say you're doing a lab and you're trying to find the height from which a ball was dropped when you knew the time it took to hit the ground, okay, or something like that. And you have two equations that you know it might be. You're thinking that height is either going to equal velocity times t squared, or height equals 1/2 times g, which is the acceleration of gravity, times t squared. So which equation is correct? Is there a way that you can just look at units to figure out which one might be correct? Well, if we're looking for a height, that will need to be in meters. So we're trying to solve and get something that is in meters. Velocity, okay, so we're going to see, is this equal? So velocity has units of meters per second, and time is seconds squared. So if we solve that one, we're going to get units of meters times seconds, okay, which does not equal meters. Okay, so one of the seconds canceled here, and I'm left with 1 second, and I still have my units of meters. Sometimes when you do this dimensional analysis, you can put the brackets around your units to show that you're just kind of showing what the units do. Okay, so that one looks like, nope, that's probably not it. Okay, let's say the other equation you had that you think might tell you the height from which the ball was dropped is 1/2 gt squared. And the units of g is just a constant. It's 9.8 meters per second squared. So the units there are meters per second squared. Okay, so those are units of g. Any number that's just a constant doesn't have any units associated with it. And then t squared is going to be second squared. Okay, so our second squared cancel out, and we're left in meters. So in this case, the units over here on the left side of the equation equal the units here. Okay, so meters equal meters. Okay, so that is a potential equation that will solve for your height. Now, this one, the units work. It doesn't necessarily mean it's exactly the correct way to do it, but it is a way you can check to make sure that you maybe are on the right track. And it can also give you confidence, okay, at least it's giving me the units that I'm looking for, and I'm on the right track. Okay, we can look at one more example. You can also use this to figure out like what the units of a quantity are, okay, by looking at what you're multiplying together, or what variables are on each side of the equation. Okay, so let's say that we wanted to find what the units of energy were. Okay, so again, we can use dimensional analysis, and we know E equals mc squared. Okay, so that's Einstein's famous equation. Okay, basically says that energy and mass kind of are equivalent. Okay, mass is just a type or a form of stored energy. Okay, so we're trying to find the units of energy here. Okay, and we know E equals mc squared. Okay, m is mass, so that's kilograms. Okay, c is the speed of light, so c is speed of light. Okay, and c is squared, so the speed would be in meters per second, and then we're going to take that and square that. So our units of c are going to be m meters squared over seconds squared. Okay, so when we're looking at for the what are the units of E, well, they're kilograms meters squared per second squared. Okay, so that is correct. That is units of energy. So kilogram meter squared over second squared. That also is equivalent to 1 joule, but that's kind of just some extra information. So kilogram meter squared per second squared is equal to 1 joule as well if you have one kilogram meter squared per second squared. Okay, so dimensional analysis can be used to kind of tell yourself if you're on the right track or not. Will your equation work to give you a value with the units that you're looking for? Okay, so dimensional analysis is useful. One, it will tell you if you're on the right track. Okay, it'll tell you if your units are what you're looking for. So you can check before you actually do the problem and plug your numbers into your calculator. You can check if you're actually getting the units you're looking for. Okay. 2, it can help determine the units of a quantity. Okay, for example, in that second example, we were able to figure out, well, we didn't know what the units of energy were, but we were able to determine from the equation that we knew that they were kilogram meters squared per second squared. Okay, and 3, the units can help in conversions. We did conversions last lesson. So when you're converting between units, write out those units to make sure they cancel, and that's another form of dimensional analysis. So basically, dimensional analysis does these things, and it's basically just making sure you write down your units and track your units throughout the problem. It's hugely helpful. If you just have numbers written all over the place, you start losing track of what you're doing. It's much easier to make a mistake. But if you're always writing out your units and making sure things cancel and you're getting to the units that you want, it'll be a huge help when solving problems in this class.